You know, in real life, it doesn't always like just jump out at you and you know things are going to work out. But since you're doing problems in a math book, hey, if they give you 4 terms, it's probably factoring by grouping. So you should have these little red flags that go off in your head. If it's a binomial and they say factor, say, hey, is that perfect squares or perfect cubes? If so, you can factor. If it's 4 terms, you should have a little red flag that says, hey, factor by grouping. And what that means is you can take 2 terms at a time. And we're going to factor them by grouping. So the first thing I'm going to do is take this x to the third minus 3x squared. Do you see anything that's in both terms? An x, good. So this is the same as x times x squared minus 3x. So could I have taken even more out? Do they still have something in common? They still have another x. So that can go all the way to x squared times x minus 3. Now we're going to take this one. There's no x's in both of them, but could negative 16 go into both numbers? Yeah, always try to pull out that first negative if you can. So I'm going to pull out a negative 16. That would leave me with x. How many times does negative 16 go into 48? Negative 3 times. Right? So I get minus 16 times x minus 3. And sometimes when you factor by grouping, like every time in your math book, but you know, sometimes in real life, it works out like this. What do you notice about the parenthetical parts? They both have x minus 3. So, quick side note, if I had 5 apples, and I also had negative 2 apples, isn't that the same as 5 minus 2 apples? Everybody agree? So you can do the same thing here. If I have x squared, x minus 3's, and I have negative 16, x minus 3's, that means I have x squared minus 16, x minus 3's. Yeah. So since I had x squared times x minus 3 and negative 16 times x minus 3, I have x squared minus 16, x minus 3's. In other words, if the thing that's on the inside is the same, it's just whatever's on the outside times whatever's on the inside. Now, I wish I could tell you that's the end of the problem. However, with factoring by grouping, you always have to check and see does anything factor again. Since I have an x squared and a 16, both of those numbers happen to be what? Perfect squares, so we know it factors again. But we should be in good practice on this one. Here's the x minus 3. This one's just x, 4, 4, plus, minus. Done. Right? Difference of squares. Square root, plus, minus. Then you're wrong. Because the problem was to factor it. Got to factor it completely. But this one should be automatic. If that's not automatic, I haven't been doing a good enough job on your homework and warm-ups. We need more practice on that? Automatic. Square, square. Square root, plus, minus. That should take you 3 seconds. What's that? Sure. If you all get a B or higher on any test, I'll get you all pizza, sure. Any test. Alright, next one, look. Next one, look. Adam. What do we have in both of these? You even have an m squared. You want to see whatever the, biggest power you can get out of both of them. So they both have at least an m squared. So I'm going to say that's m squared. In the first term, that would leave me with 3m. In the second term, negative 1. Alright. In the other one, plus 9m minus 3, I could take out a what? Positive 3. Good. That would leave me with 3m minus 1. Also, once you factored the first one, it should be like a little hint. You're like, hey, I want to end up with 3m minus 1 so it matches up. So what would I have to pull out to get that? Now, since I have the same thing on the inside, you take what's outside, m squared plus 3, and what's inside, 3m minus 1. Now I have a binomial with a squared. You got to check to make sure they're not perfect squares. That's perfect square. Is 3 a perfect square? No, so we leave it like that. And Brainod's happy. He already was hungry, and then we got all this making him hungrier. Questions on that one?